Namaste everyone, this is Dr. Aisha Butalia. Our today's topic is reinforcement learning. This topic comes under machine learning and AI, and we have already taken this topic earlier also. The link, I will share it in the description box. That was a similar session topic based on the research paper. And today I recommend this website javapoint.com/reinforcement-learning, where you will be knowing the components of reinforcement learning in detail. So in our last session, we discussed that reinforcement learning is based on experienced learning. Of course, we have prior art or prior history-based learning. Okay, that is called supervised learning. We have got reasoning-based learning. We have got context-based learning. We have got concept-based learning. And what comes under experience-based learning, for which the technique which is very popular, that is SVM, support vector machine. Okay, so that incorporates reinforcement learning. So apart from the two other paradigms, there is one more paradigm of learning in machine learning. The two other paradigms are supervised learning and unsupervised learning. And the third one is reinforcement learning. The other perspective of reinforcement learning is feedback-based machine learning technique. So it is also not only experience-based, but it is also incorporating the feedback. Now, feedback is based on experience indirectly. For example, the students who attend the lecture, they are asked how their experience was about the lectures conducted by a particular faculty on a particular subject. Okay, so that is the feedback they share based on the experience they attended the lectures. Those students who have not attended the lecture probably may not give a proper feedback, or maybe they will give a temporary feedback based on one or two lectures, or maybe a scoldings from the teacher. But the actual experience, who has attended maximum lectures, of those students, the feedback is taken. Sorry for the disturbance at the background. We'll continue. So it is in which the agent has to behave in an environment by performing action and seeing the results of actions. For each good option, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. Okay, for example, if suppose there is an feedback which is positive, so of course you'll get a reward. And if there is a negative feedback for something, you may get a penalty. So it's normal how we behave using a feedback system. Same we have to incorporate in machine learning. So in reinforcement learning, the agent learns automatically using feedback without any labeled data, unlike supervised learning. Okay, so basically for unlabeled data, we have unsupervised learning. But apart from unsupervised learning, which is totally, you have to start from scratch. Here, the reinforcement learning is between that. We cannot say that it is semi-supervised learning, because semi-supervised learning is a combination of supervised and unsupervised. But reinforcement learning is totally based on experience, and based on the experience, the feedbacks given, okay, without any labeled data. So that you need to note that you can even work on unlabeled data using reinforcement machine learning. Since there is no labeled data, so the agent is bound to learn by its experience only. So what I was telling you, that this is based on experience. So this is what it is mentioned. So experience and feedback, the combination is reinforcement learning. RL solves a specific type of problem where decision making is sequential and the goal is long term, such as game playing, robotics, etc. So where, it is sequential. Why it is called sequential? Because unless and until you have experience, you cannot give feedback. Okay, that's why it is sequential. And it's a long term, because experience cannot be gained in a short-term process. You cannot attend 2 lectures and you can say that, okay, I'm now experienced to give that feedback, right? So henceforth, it is called, it is a long term. So the applications where it is mostly used, of course, this is not limited, but to name a few, is game playing and robotics. So this is another definition, but actually it means the same, that it is also used as an intelligent AI agent. That is why it is also used not only in machine learning, but also in robotics and in artificial intelligence. So it is also the environment where it works. It is also called as the AI agent, okay, which works on the concept of reinforcement learning. So the example is given here where a scenario is that the AI agent present with a maze environment. Maze is like, we are going to try, solve a puzzle types, right? And his goal is to find the diamond in the environment. So the agent interacts with the environment by performing some actions. And based on the actions, the state of the agent gets changed. And it also receives a reward or penalty as a feedback. Okay, so here we'll see a diagram to better clear this example. So this S is state. So S1 state, S2 state, S3 state, right? This is a robot and this is the diamond and this is a fire. So robot, if it needs to travel to find the diamond, it can have n number of states and different paths, right? So it depends what path it takes and it will get a reward or a penalty. If it goes right, it's a reward. If it goes wrong, it gets a penalty. So coming back here, so the agent continues doing these 3 things: take action, change state, remain in the same state, and get feedback. Okay, so these 3 things the agent does in reinforcement learning. And by doing these actions, he learns and explores the environment. So the terms used in RL, the agent, the environment, the action, the state, the reward, if it's a positive feedback, the policy. Okay, if it's a negative feedback, it will be termed as penalty, and policy, then value. Now, what is policy? Policy is a strategy applied by the agent for the next action based on the current state. Okay, so there has to be certain rules, okay, which will identify what has to be done next. Okay, and then we have value. So it is expected long term returned with the discount factor and opposite to the short term reward. Okay, so it is an expected long term returned with the discount factor and opposite to the short term reward. So if something is long term, then it will be called as value. And if it is a short term, then it will be termed as reward. Okay, so reward we have here and long term reward is called value. Q value is the most similar to the value, but it takes one additional parameter as the current action. Okay, so current action plus the next reward value and the plus the reward value, they both together form the Q value. So this is quite what we discussed. You can go through the key features on this site. The approaches which the RL used are namely 3. One is value-based, another is policy-based, and third is model-based. So value-based is about to find the optimal value function, okay, which is maximum value at a state under a policy. Okay, so whatever regulations we form, and at that regulation, we have to find a function, and the function is such, okay, which gives us the maximum value. Okay, that is called as the value-based approach. So therefore, the agent expects the long-term return at any states under policy pi. Okay, so the agent expects long-term return. Of course, we all want long-term. Okay, and for that, we try to formulate the best policy and we call it as pi. Now, second is policy-based. So policy-based approach is find the optimal policy. Here we are finding the optimal function. Here we are finding the optimal policy. Of course, for the same outcome, that is maximum future rewards. okay, without using the value function. Here, value function is used, here value function is not used. So in this approach, the agent tries uh, to apply such a policy that the action performed in each steps helps to find the maximum future reward. So mainly policy based has two types. One is deterministic and one is stochastic. The deterministic approach, okay, the same action is produced by the policy pi at any state. Whereas in stochastic, probability determines the production action. So this will not change. The same action will be performed by the policy on every state. Okay, the policy, of course, the policy is changed and the same, and the action is also same to be taken on every state. Whereas in stochastic, on every state, depending upon what the probability is, okay, so the action may change. Third type is model based. In model based approach, a virtual model is created and the agent explores the environment to learn it. There is no particular solution or algorithm for which approach because the model representation is different for each environment. Please skip the ads in between, just ignore them. We'll concentrate on only our material. So the elements of RLR policy, as we discussed, the reward signal, the value function, and the model of the environment. So these are the elements. So if you get a question, okay, what are the elements of RL? So you have to answer these four. So we already discussed what the policy is, okay, but and the two types, that is deterministic policy, where it is denoted as A of pi of S. This will be constant, the action will be constant for every state. Whereas in stochastic, based on the probability, okay, the function, the stochastic, the state action would change. Okay, so for every action, the action would be taken on every state based on the probability. So we have got reward signal. We know that if the positive outcome, otherwise there is a penalty. If the value function is, it gives information about how good the situation and the action are and how much reward can an agent expect. So we want the maximum reward. Okay, so the function is, value function is defined that. So a reward indicates the immediate signal at each good and bad action, whereas the value function specified the good state and the action of the future. Why it is only the good state? Because initially we discussed that value function gives us the maximum reward. So if it's a reward, it has to be a good state. Okay. Model, the last element of reinforcement learning. Okay, it is the model which mimics the behavior of the environment. So it's a model based behavior of the environment. For example, when we create a building, before a building, there is a small toy type building structure created. Whenever there is a client coming in to book or see the flat, okay, they are told that, okay, it is under construction and probably the roads will be from here, the swimming pool will be here. So it is a mimic of the behavior, how the particular entire society is going to look like, okay, whenever it will be developed in future. So that's called model. So it's not a realistic, it's a simulation probably. So with the help of the model, one can make inference and how the environment will behave. Okay, so you just get an idea about it. So such as if the state and an action are given, then the model can predict the next state and behavior. So basically machine learning is a prediction model. We are supposed to predict what we right now don't know. Okay, so that's why this approach is used. So the model is used for planning, which means it provides a way to take a course of action by considering all future situations. So all assumptions are taken care. And with the help of this model, as termed as model-based approach. Okay, so to solve the feedback-based learning paradigm, that's called the reinforcement learning. So comparatively, an approach without using a model is called as model-free approach. How does reinforcement learning work? So you have an environment, okay? It can be anything, say room, maze, football ground, etc. You have an agent, an intelligent agent such as an AI robot. Okay, so let's take that example where the robot wants to search the diamond, right? So there is an image here. So in the above image, the agent is at the very first look of the maze. The maze is consisting of the S6 block. Okay, this is the S6 block, which is a wall. S8 is a fire pit and S4 is a diamond block. So the agent cannot cross the S6 block because it's a wall, as it's a solid wall, right? So if the agent reaches the S4 block, if the agent reaches the S4 block, it reaches the S4 block, okay, then get the reward +1. Okay. If it reaches the fire pit, it gets reward -1. So reward -1 is basically the penalty. So it can take 4 actions: move up, move down, move left, or move right. Okay, so these are the 4 actions which the agent can do. So agent can take the path to the final point, but he needs to make a possible few steps. Suppose the agent considers S9, S5, S1, S2, S3, okay, to reach our target, okay, to get the reward +1. So the agent will try proceeding the steps to reach the final step. To memorize these steps, the assign value 1 to each previous step. Okay, so we will have value 1 here, then value 1, 1, 1, 1. Okay, so this is going to work like this from here. So now the agent has successfully stored the previous step's value 1, okay, for each block. But will the agent do it if he starts moving from the block, which has one value block on both sides? Okay, so what it is now, it has reached here. So it has to decide whether it has to go down again or go right, because both the value are 1, 1 over here. It gets confused. Okay, so that decision needs to be taken. So it will be difficult condition for the agent, okay, where it should go up or down as each block has the same value. So the above approach is not suitable for the agent to reach the destination. Okay, there is an ambiguity created here. Hence, to solve this problem, we use the Bellman equation, which is the main concept of reinforcement learning. So I'll again repeat. Here, after coming, the agent comes here. This is also one, this is. So it gets confused. Okay, because at point of time, it is using an algorithm. Okay. So here, since both the sides it is 1, at a point, it gets confused whether to go here, it is in the right direction, or here it is the right direction. So to solve this, we are using a feedback system learning paradigm that's called reinforcement learning, which is based on the Bellman equation. So there was a lacuna in this loophole in this algorithm, hence the invention of Bellman equation, which is the main concept behind the RL. So let's see what is the Bellman approach. So the Bellman equation was introduced by mathematician Richard Ernest Bellman in the year 1953, and hence it is called Bellman equation. It is associated with dynamic programming and used to calculate the values of the decision problem at a certain point by including the values of the previous state. It is the way of calculating the value functions in dynamic programming that leads to modern reinforcement learning. So the key elements used in Bellman function equation are as follows: the action, okay, performed by the agent, that's referred as A. State occurred by the performing the action S. The reward feedback obtained for each good and bad equation that we call as R, and the discount factor that is called as gamma, okay, denoted by the gamma symbol. So the equation is written as V of S max of RSA plus gamma V of S. Okay, so these notations you need to revise 2-3 times and then evaluate on this function. So this is the Bellman equation given by the scientist Bellman, already mentioned, the mathematician. And what is V of S? The V of S is value calculated at a particular point. RSA is the reward. Okay, it is the reward at a particular state by performing an action. Y is a discount factor. And what is V of S dash? The value at the previous state. So this is at the particular state, or you can say the current state, and V S dash is of the previous state. So in the above equation, we are taking the max of the complete values because the agent tries to find out the optimal solution always. So now using a Bellman equation, we will find value of each state by giving environment. So for the first block, Vs of 3. So if we go over here, Vs of 3 is this, right? So we have to use the maximum of the Bellman function. Okay, we want the optimal solution. That's why we use the max function. As we already said that the value function or the uh, policy, it has to be the maximum value, right? So for the first time, the state would be zero because the initial state, right? So there is no further state to move. So hence it will be, the previous state would be zero. So only we have to consider this as max RSA, okay, which will be max of 1 because we are termed this as 1 initially. For the second block, that is S of 2, okay, we will consider max RSA and the previous state. So previous state was calculated as 1. Now here, the discount function gamma is given as 0.9. That's assumed, okay, that's given already. And we will assuming the previous state as 1, not assuming, this is termed as 1 from here. And RSA is 0. There was no reward at this state. Okay, so that is why we will use max 0.9 is gamma. Okay, and the previous state is 1. So we will get it as 0.9 into 1, that is 0.9. For the third block, of course, again, there was no reward, okay, in the previous state. So that would be skipped and only this will be considered. So you will have the discount would be 0.9, 0.9 into the previous state. So previous state was 0.9. So 0.9 into 0.9, that will be for the third block. The same calculations would be there. Okay, and the fourth block, again, the same calculations will be there. Okay, so the previous state and your gamma, that is the reward. That is the discount. Okay, so this is way we will calculate using the Bellman equation. Okay, and we will put these into the calculated values over here. Fine. So now we will move further to the sixth block, and here the agent may change the route because it tries to find the optimal path. So now let's consider from the block next to the fire pit. So you can start again from here, the route. Okay, so here, because there can be here and here. So you can start this route again. And similarly, you can calculate it because now since if it goes here, the reward would be -1. So you can calculate similarly with now reward also as -1 and go to the next moves. So this is how the values would be calculated in the similar manner using Bellman equation. So the types of, initially we discussed about the elements of RL, that were 4, okay, model being the last element. The types of RL are positive reinforcement and negative reinforcement. So of course, if there is a positive reward, it will be a positive reinforcement. If it's a penalty, then that's a negative reinforcement. So you can go through this. So the positive reinforcement learning means adding something to increase the tendency that expected behavior could occur again. Okay. It impacts positively on the behavior of the agent and increases the strength of the behavior. This type of reinforcement can sustain the changes for a long time. But too much positive reinforcement will lead to an overload of states that can reduce the consequences. Whereas what about the negative reinforcement? The negative reinforcement learning is opposite to the positive environment, and it increases the tendency that the specific behavior will occur again by avoiding the negative condition. It can be more effective than the positive reinforcement depending on the situation, the behavior, but it provides reinforcement only to meet minimum behavior. Okay, so at times even negative reinforcement is of use because we know that, okay, this is the path we should not follow. Okay, this is the minimum case we should follow. And for positive, it is the maximum case we should follow. So those types of states we should paths and actions we should maximum follow, and which are giving the negative reinforcement or states, we should follow that path as minimum as possible. So even the negative reinforcement gives us a picture what to avoid, right? So as I always say that even if you have done a research which has given you a wrong or a negative result, then also it is called as a positive research. Why it is a positive research? Because we at least we have come to know that this technique or this algorithm, we need not use it in future and waste our time. So that is also a positive research in some or the other way. So these both types of reinforcement learning are positive reinforcement learning only. The only thing is these are the different environments which we study. Okay, so we will stop here for the topic reinforcement learning in short. Okay, what are the types, what are the elements, what are the states, and how to go about it, and the main theme behind reinforcement learning, that is the Bellman function. Okay, in detail, we will be studying the pros. Pros we have already discussed, and there were the cons, which we said that we did not come to know which state to go, as all initially were one. Okay, so it created a lot of ambiguity. Hence, we came to Bellman's. So now we will see the later states, that is called as the Markov chain for complex structures. So in the next lecture, we will be discussing about the Markov states, the Markov property, the hidden Markov model, okay, and so on, in which is the extension of the reinforcement learning. So thank you very much for your patience listening. I hope this topic continued from the previous lecture, which was based on that different types of learning paradigms and how reinforcement learning is based on experience, and this an extension as a feedback based on experience, and the Bellman equation is helpful to you to understand this concept. Thank you for your patience listening once again. This is Dr. Aisha Butalia signing off.